Okay, so today we're going to talk about quality management. And of course, remember I've said previously that quality is the conformance to requirements.
Yep.
So we're going to define quality and quality management, and then we're going to differentiate between and among the various aspects of quality. And again, because this is a potential fodder for questions, are you doing quality planning or assurance or control? And we're going to talk about the cost of quality, which is definitely a concept in total quality management, which is another one of those realms that's briefly touched on in the PMBOK, but a little bit more is expected of the project management professional practitioner. And then we're going to look at the processes and talk about the 7 basic tools of quality. Again, a total quality management concept that's briefly discussed in the text, but you might want to look into it. And then also Six Sigma. So again, quality, so the definition of quality is the degree to which a set of inherent characteristics fulfills requirements. And this is the ISO 9000 definition. So basically, my shorthand for it is conformance to requirements. So it's not so much a goodness thing. If you think of, if you buy a high quality purse or if you buy a high quality car, it's not really that so much as it's conformance to requirements. It's not like a luxury thing. So again, a project is said to meet quality expectations when all the project requirements agreed to in the beginning, i.e. all the requirements, are met at the resulting product is usable. Because of course, you don't want to have, do you remember those MC Escher pictures where the one hand is drawing the other hand, and you can draw things that can't be built. So you have to have reasonable and non-conflicting requirements. So the following terms are related to the concept of quality, and that is, of course, customer satisfaction, and then we're going to talk about grade and, distinguish various grades of products, as well as precision, which is versus accuracy. And those are kind of two sides to a coin in terms of, you can be very precise and not be accurate, and you can be very accurate, or you can be accurate and not be very precise. So we're going to talk about all of these things in the future slides. So the optimal level of quality is obviously a trade-off. In other words, if you look at the diagram, there's incremental revenue and incremental cost, and the optimal level of quality is where those two things intersect. Because obviously you can put all kinds of effort into something and being very exactly perfect, but again, the right answer too late is not the right answer, or at least not a useful answer. And if you spend a fortune, for instance, making a car entirely and absolutely safe, it may not be usable, or it may be so expensive that it's unattainable by the mass market, or in fact any of the market. So the example here is a toy manufacturer that's not selling because of poor quality, and so they do a lot of mitigation factors to try to work on that and then re-engage their buyers. But again, that additional investment increases the cost and then might make it too expensive. And of course, you've got to hit that happy sweet spot. And also, as I said before, you never get a second chance to make a first impression. So it's probably more expensive to lure buyers back than to obtain them in the first place. So quality management has basically 3 processes. You've got quality planning, because you've always got a plan. You've got to have quality assurance to make sure that the processes that you have set in place are actually followed. And then you've got to have quality control to look at what's working and what's not. Obviously, if you have intended a process to make things better, easier, faster, more adherent to the requirements, and it's anything but that, you definitely don't want to keep doing that. And as likely in your change management process. If you institute a change with a desired effect and it doesn't have that effect, you don't want to do it. So let's look at quality planning and quality assurance and quality control in kind of a matrix form. And basically, the planning tells you what you're going to do. So you prepare the plan and you focus on what, how you're going to, what level of quality you're going to have and how you're going to achieve it. And then quality assurance is how you're going to comply. So basically, how you're going to do it in terms of, say, audits or what you're going to do about deviations and maybe corrective and preventative actions. So again, this is more of the process and not the product. So remember, we have that dynamic tension, if you will, between the process and the product in terms of definitionally looking at what processes affect which part of the product or the process. And then finally, the quality control, which is product-based, and that looks at the specific results against standards and revolves around inspecting and verifying. But remember, in terms of quality, you can't inspect conformance to requirements or quality into a product. Either it's there and you see it, or it's not there and you see it, or unfortunately you don't see it and then the product gets into the hands of the end user, which might not be a bad thing. Which might be a bad thing. So here's an example where a project was planned to be completed and virtually everything is intended to be within 10% plus or minus of the budget. And it's usually never minus, let's face it. So 3 months ago, the project, obviously not complete at that point, was 20% over budget. And with 1 day to go, they looked like they were going to be 15% over budget. So in a way, they've improved because they went from 20% over to 15% over, but they're still 15% over. So since there's an improvement of 5%, it's likely that over the next 3 months, the cost would reduce and the project would get completed within the plan limit if there was 3 months left. But if the cost increases further, obviously you have to take corrective and preventative actions to bring the product back into the agreed limits, and that's quality control.
Okay.
So here are some concepts from the total quality management arena. And again, you won't be tested in depth about these, but the more you know, the easier it is to answer questions and to ferret out the bad answers. So total quality management is an integrated philosophy, and this is continuous improvement. And as I said, that PMI has a big push towards continuous improvement. So whether it is you personally as a project manager, or whether it is your team as project management or team professionals, that everything should always improve. Your processes should improve, your communications should improve, everything should always be continually seeking to get better. So that's one reason for following a lot of well-stated procedures and documenting everything. That way you can tell where you've been and where you're going. There's the Deming, and actually Short was Deming's co-author, on the Plan, Do, Check, Act. So this is kind of a framework for process control and improvement. And it's also kind of the tenet of the spiral life cycle, where you plan some, you do some, you check it out, and then you act on it. So basically, the iterations of the spiral life cycle model could say to be following the Deming Plan, Do, Check, Act cycle. And then there's Kaizen, which is, and I've probably absolutely botched that speaking of the word, but it means change for the better in Japanese. And so this is the philosophy that looks for small and continuous improvements in a process. And this comes out of the post-World War II rebuilding of Japan, and the major car manufacturers going over there. So it was, General Motors and Toyota, and what they did, because basically they were starting from scratch, a lot unbuilt towns, because a lot of those places had been bombed flat. And so they went over with basically a clean slate, but a usable workforce to basically re-engineer their processes and things. And another concept is Kanban, which is a pull-based inventory based on the Japanese principle of just in time. So rather than having a lot of inventory on the shelf, you have it there ready just when the people want it. Grocery stores pretty much do that all the time, because obviously anything that gets beyond its useful date is tossed because it's expired, and especially produce expires pretty quickly. So there's a lot to be said for not having to store and manage inventory. So the cost of quality, when you think about it, is actually a cost. So it breaks down into two basic components. One is the cost of conformance, which are the prevention costs to prevent errors and to produce good products. So you want to have, like in your case, you want to have good training for your employees. You want to document things so you know what you did, so you can do the good things over again and not do the bad things, hence the lessons learned. You want to have good equipment, say sharp scissors if you're cutting things, because dull scissors are just a bad thing. And you want to have adequate time to do it right. I talked about the old project that I was on that was really a 5-year project. They wanted done in 3 years. So when you don't have the time to do it right, you often have to do things over. So, and then another cost of conformance is the appraisal cost. In other words, obviously you have to perform testing and, say, inspections. And if you do destructive testing, say you're building fire extinguishers, anytime you use a fire extinguisher to see that it has the appropriate amount of the fire extinguishing chemical, then that fire extinguisher is destroyed, so therefore not usable. So obviously the cost of quality is producing a little bit more than you need in the case of destructive testing. And I don't know, in your facility, do you do destructive testing, or does the manufacturer?
Yes, they do.
So so that's a little bit of overage you've got to build into the plan.
Yep.
And then there's also the cost of non-conformance, and that is internal failures that show themselves before the product is released. And that means that you've got to do rework, and you've got to send that off to scrap. So you've wasted some amount of time and you've wasted some amount of material. And then you've got external failure costs. And like we were talking about in the toy manufacturer case, this is the cost after the product is returned to or sent out to the customer or the end point user. I mean, it could be within your organization, but the problem is you might have liability if you put out a car that crashes, or the gas tank blows up. You might have to do warranty repairs. I know I had a Swiss Gear backpack that I sent back, and they basically had to send me a new one. So not only did they have to send me a new one, which then basically they lost probably all the profit they made on the first one, but they had the postage back and forth. And then potentially you lose business if people think your product's not reliable. And as I said, you don't get that second chance to make that first impression. So goodwill is also a problem. So when we talked about organizational structure and how even your peer project managers were stakeholders in your project, it is potentially because if you put out a bad project, then all of your peers are going to be under the cloud of whatever poor quality product you put out there, which means that it'll be harder for them to sell their products. So like in the case of the toy manufacturer, if you put out one video game that's glitchy or that fries the people's systems, then anything else put out by that manufacturer is going to be suspect. So basically you're going to be quizzed on the cost of quality. Basically, we've got the two components, and you may have to identify which would be part of the cost of conformance to quality or the cost of non-conformance. Okay, so we're going to talk about the 3 processes of the quality management knowledge area in more depth, and we've already kind of tipped to those. And in the planning phase, you have plan quality management, which is very aptly described in terms of its location here on the matrix. We have manage quality, and again, the word manage means it's in the executing process group, and obviously it's got quality in the name. And then we've got control quality. So again, that's good because we've got the quality and the control work, so we can pretty much slot those in if we had the blank matrix and we had to put the 3 processes into it. So our first process is the process of identifying quality requirements and or standards for the project and its deliverables and documenting how the project will demonstrate compliance with relevant quality requirements. So we use kind of our typical inputs, the project charter. And remember, the project charter had the high-level cost and schedule and scope and risks, and it also had the high-level requirements. So the project charter is an important input. And then we've got the project management plan and all of the aspects of the project management plan, of course, some of which we haven't discussed yet. And then we've got our EEFs, and you remember, are those internal or external?
That is external.
Correct. And then we've got our organizational process assets, and of course, that being the other side of the coin, those are then necessarily internal. So the tools and techniques that we'll use to plan quality management include our expert judgment and decision making. We'll gather data and figure out how to represent data, especially when we talk about the 7 measures of quality and all the ways to gather and measure and accumulate data. We'll do data analysis, and of course we'll have test and inspection planning, and of course the inevitable meetings. So those are all the tools and techniques of the planned quality management process that lead to the outputs, including the quality management plan. And again, that follows very well with the name of the process. And then we'll come up with quality metrics and potential project management plan and other document updates.